So I'm just going to really quickly review factoring with you, a couple types of factoring. One is factoring out of GCF. So this first problem, there's only two terms here. What we need to do is look at each part of each term and ask what do they have in common. Can you guys think of a number that we can factor out of both a 6 and an 8? Something that divides evenly into 6 and 8. 2 goes in there. Is there anything bigger that goes into both of those? We always want to try and get the biggest number. I don't think there is. 2 is the biggest number that we can divide out of both of those terms. Think about the variables, the x to the third and the x. What is the greatest amount of x's that we can pull out of both of those terms? So I can pull 3 out of this one, but I don't have enough to pull 3 out of this one. So 3 is too many. We can pull 1 out of this one. We can definitely pull 1 out of this. So I'm going to pull an x out front as well. Now I just need to figure out what goes inside here. And this is kind of like distribution, but in reverse. What would I need to put in here so that when I multiplied it by 2x, I got 6x to the third? I think that's going to need to be a 3. 2 times 3 will get me this 6. And I've got an x here. I need 3 x's, so I'm going to need 2 more x's multiplying in there. And then what do I need to multiply 2x by to get 8x? That would be 4. Do I need any more x's? I've already got the 1 out here. I'm only looking for 1. So that would be my final answer. That is factored. Any questions on factoring a GCF? Is that coming back now that you've seen one? All right. This next part is factoring a trinomial. Can I get you guys to pay attention, please? Did you finish these up? Okay, you got them. Never mind. Factoring a trinomial. This is a long process. We taught, if you are a sophomore, you would have learned this Xbox thing last year. I'm not sure, does the middle school teach this Xbox thing too? So most of you have seen this method. There are other ways to factor trinomials, so if this doesn't work for you, let me know. I'd be happy to show you some of the other ways that I know. So the big idea is we build the x. We start with a, b, and c. A is 1, because there's an invisible 1 in front of that x. B is 3, and c is negative 18. And when we build our x, we multiply a times c, that goes on the top. So 1 times negative 18 goes on the top. And on the bottom is whatever the b value is, which is 3.
Wait, where are we supposed to got it from?
They came from our original problem here, this 1 and this negative 18. 1 times negative 18 is the negative 18. So 8a times c. Oh, you thought my a here was a 9? That would be confusing. I'm sorry about that. Are we good with a times c? And then b is 3. That's why that's on the bottom. You guys did a bunch of diamond problems last year. This becomes a diamond problem now. I'm looking for 2 numbers that are going to multiply to give me negative 18 and add up to 3. And 3 and 6 are going to work if I make the correct one negative. One of them needs to be negative. If they're going to add up to positive 3, I think I want the smaller one to be negative. So I got a negative 3 and a positive 6. And of course, if you flip the negative 3 and the positive 6, that's fine. Those 2 numbers go into your box in these 2 spots, so negative 3 and 6. And the rest of your box comes from the original problem. So I had already filled in the x squared from here and the negative 18 from here. So there's a lot of different pieces you got to get in the right place. To come up with our final answer, I need to come up with some numbers I can put on the outside here that would multiply to give us all that stuff. I like it when this is an x squared because the only way to get an x squared is x times x. And then I'm going to focus on my top row here and ask myself, what do I need to put up here so when I multiply it times x, I get 6x? Well, that must be a positive 6. And then I'll focus on my column here and ask, what do I need to put in this spot so when I multiply it by this x up here, I get negative 3x. And I think that needs to be a negative 3. And I'm just going to check as a final check, does the negative 18 work out from that negative 3 times that 6? It does. So there's my final factoring, x plus 6 and x minus 3. We will continue to practice these in our warm-ups. If this is a little unfamiliar for you, that's okay. We'll continue practicing these. I'm going to go over several more of them with you before I kind of leave you on your own to do your own. Okay, any questions on factoring? Yes? Why is it just the 3 by itself when it's plus 3x? Are you talking about this 3 here? The one here? Down here? Oh, okay, great question. Question is, why is this a 3 and why is it not a 3x? Some people put the x's in. Do you put an x square up top? Did you put an x squared up top? Okay, so that's a kind of a different style. Some people would put an x squared up here and x down here and then an x here and here. I usually don't do that though. When I do my diamond problems, I only put numbers into them. I don't put the variables into them. And I just look at the coefficients that are in my problem. So I don't, the fact that b is 3 is because the 3 was attached to an x, but when I use b, I don't put the x onto it. b is just the number in front. Does that answer your question? Great question. Thank you for that. There are different styles. Like I said, I know of at least 5 ways to go through this process. And then kind of different variations on those as well. So if you're putting x's in here, that's fine with me. If you know another way to factor and you're able to come up with the same answer, you don't have to do this x box thing. In fact, when you get to pre-calculus, I hope you are not using this x box thing because it's way slower than it needs to be. Okay, we're going to move on unless there's other questions. All right, let's do this.